Let's review the E2 elimination a little bit. So to do an E2 elimination, there are really three things that I look for. One, we need a strong base. We also need a leaving group of some sort. When we learned about the E2s, we learned them in the context of alkyl halides. So typically that leaving group is a halide. Could be something like a tosylate. That's fine too. And then we also need a beta hydrogen. Those are the three big things. What you may not realize is that the relationship between the leaving group and beta hydrogen is kind of a special relationship. They should be anti to one another when the reaction occurs. Okay, anti. When did we learn the term anti? Well, this is a term that got introduced when we learned about Newman projections. So we need to go back to a Newman projection. So let's draw a molecule that could do an E2 elimination. I'm going to draw a general structure. It's not a real molecule. But we're going to have an X. This is our leaving group. And then we got other stuff coming off these carbons. And then we have a hydrogen. So the leaving group is attached to what we call the alpha position. And then next door is the beta hydrogen. So we want to look at this as a Newman projection. So we draw a circle. It's a pretty sloppy circle, but you get the idea. So we have our hydrogen. We're going to kind of look down this, take this perspective on the molecule. Hydrogen. We have these two carbons coming off, these two groups. The other two groups will be pointing down on the back carbon, and our X, our leaving group, will be poking up on the back carbon. So here is, that's a horrific bond there. Apologize for that. Here's our beta carbon, and that bears our beta hydrogen. And the back, behind the beta carbon, we can't see it, is our, because it's behind it, but there's an alpha carbon back there, and the X group is coming off that alpha carbon. So what's going to happen is, our nice strong base is going to come in, it's going to attack that hydrogen, remove that hydrogen. It's going to break this CH sigma bond, and those electrons, it's hard to show on this Newman projection, but they're going to go between the alpha and beta carbons. Let's draw it over here on our sawhorse picture. And that's going to kick out our leaving group, and our leaving group will get kicked out. So the orientation, remember there's a Newman projection, the orientation of our leaving group and our hydrogen, these are anti to one another. They have a dihedral angle of 180 degrees. So this brings in a whole nother layer of complexity into the E2 reactions, and it's going to have big implications on the stereochemical outcome of the reaction. So we'll see what those layers are in a later video.